So in this video we're going to find and then analyze graphically the critical points for a function of two variables to see if we have a relative minimum or maxima. So here's our function of two variables, and we want to determine whether it has a relative minimum or maximum. So we're going to find the critical points, and then we'll graphically analyze the critical points to see if we have a relative minimum or maximum. We'll do an algebraic technique for doing the same thing in a future video. So to find the critical points, we need to find those places where either the partial derivatives are simultaneously equal to 0, or places where the partial derivatives are undefined. So the first step in finding the critical point is to take the partial derivative of f with respect to both x and y. So the partial derivative with respect to x is just going to be minus 2x plus 4 from right here. So minus 2x plus 4, taking the partial derivative with respect to x. We're only going to worry about those terms. Everything else will be treated as a constant and have a derivative of 0. And then the partial derivative with respect to y. We just need to find the terms that have the y's in them and then take the derivative of those terms. So we get minus 6y plus 6. And when I look at these two partial derivatives, I see they're just equations of lines. So I know that they are everywhere defined on the interval from negative infinity to infinity. So there isn't going to be any place where the partial derivatives don't exist or are undefined. So now I just need to find out if f sub x and f sub y, the partial derivatives, can be simultaneously equal to 0. So to do that, we just set the partial derivative equal to 0 and see if it's possible to solve it. So in this case, we would get, when we solve this, we get x equal to 2. Subtract that 4 from both sides and then divide by the negative 2. And when we take this partial derivative and set it equal to 0, we're going to subtract the 6 from both sides and then divide by negative 6, so we'll get y equal to 1. So this tells us that the derivative in the direction of the x-axis is always 0 when x is 2, and the partial derivative with respect to the y-axis is going to be always 0 when y is equal to 1. So for them to be simultaneously equal to 0, which is where the critical points will occur, we're going to need the ordered pair 2, 1, the only ordered pair at which both derivatives will be simultaneously 0. So this is our critical point. And instead of doing an analytic approach to determining whether this is a relative max or min, we're just going to do a graphical approach. So we'll take and look at the graph of the function and analyze it graphically. So I'm going to keep those. I've pre-graphed the function, so the function f of xy is sitting right here, and I can see that the critical point is going to correspond to a maximum in this case. I can actually plot the point explicitly into the graph, and to do that, down on the input bar, just make your ordered triple, input 2, input 1, so if x was equal to 2, y was equal to 1, and then our function name up here is f of xy, so down here type f and put your function notation and type the ordered pair into it. So f of 2, 1. And when we do that, the point 2, 1, 2 shows up on the graph, and graphical inspection tells us that this corresponds to a local maximum.